So in last two videos, we discussed about PMF, PDF, and CDF. So in this video, we are talking about joint distribution, and it's a very important topic. So let's begin with it. So far, we have done one random variable at a time, but in reality, real data sets, we have multiple random variables. For example, there are multiple features in a data set, right? So a joint distribution describes the probability of a structure of two or more random variables together. Uh, what it actually does, it captures not just the individual behavior, but how the individual behavior interact with each other. Okay, so everything about the individual random variable can be recovered from the joint distribution. But from joint distribution, we cannot recover all the individual random variable values. Okay, the distribution is the complete probabilistic description of a random vector. Moving forward, there are how you like there are two things in it: discrete and continuous. Like for discrete data and continuous data, for discrete we use joint PMF, and for continuous we use joint PDF. Simple. Now there are the formulas here. Simple. And how we do integration, we just integrate on both variables, like x and y are two variables. So integrate. Here is the summation, and here we do integration. Simple. Now, moving forward, actually, one of the thing is like joint CDF. It works for both discrete and continuous. Okay, so remember that thing also. And here's the formula. And for what we say to get the for continuous, we just integrate it from minus infinity to x and double integration like minus infinity to x, and second integration will be minus infinity to y. And for recovering the PDF, we do double differentiation like shown here. First with respect to y, then with respect to x. Okay. Now next topic is marginalization. What is this? It is just summing or integrating out the other variable collapses to the joint to individual behavior. Okay, so these are the formulas. Here, discrete margin, and here is the continuous margin. In this we do summation, in this we do integration. Okay, simple. Now it is how visualize the visualization of marginalization. Okay, so you can see it from here. More if we go down, it is just independent. Okay, independence in terms of joint distribution. X and Y are independent if and only if probability of this xy is equal to probability of x into probability of function y. This is for discrete, and for continuous we just use functions. Simple. So in joint distribution, like it is equal, joint distribution is equal to product of the marginals. This is the formal definition of independence of random variable. Okay, so yeah, if these are not equal, it's dependent, means for structure, and if they are equal, it will show independence, right? There is no interaction. Now moving forward, it's the hierarchy of information. Nice. Now it's the questionnaire. Okay, so what this question says that x is equal to result of a diary and y is equal to 1 if die is greater than equal to 3, else it's 0, right? If y is 0 for value less than 3, right? So just we kept it 0. And when y is false, for greater than 3, its value is like 1, means it will occur. So how much equally distributed? So how many sample spaces are there? 6. So how much each event the probability will be for occurring will be 1 by 6. So this is the table which we draw. Now verify that all entries are greater than 0 or equal to 0. Yes, it is. Now sum of all entries is equal to 1. Yes, that also is true. Now compute that what we asked, like why um no. Now compute that probability of x less than or equal to 2 at y equals to 0 is how much? It is 1 by 3. How? Uh, how? Just 1 by 6 plus 1 by 6 in two times, like for less than equals to 2 na? So this just add this and it will be 2 by 6, it will be 1 by 6. Now take independence, whether they are independent or not. So probability of x at 1 and probability of y at 0 is how much? Into probability of y at 0. What is at x equals to 1? It is 1 by 6, right? And at y equals to 0, how much? It's 3 by 6 means 1 by 2. Now the product is how much? 1 by 6 into 1 by 2 is equals to 1 by 12. And their individual product is not equal to product of their like from at 1 comma 0 value, right? So it is not independent. Now, this was example of discrete. Taking example of continuous, it is also simple. Like in this question, it's given like 6xy square. Other from 0 to 1 for value of x and y. Otherwise, it's 0. So what we will do, we will just first do verify normalization. So how you will do, just integrate it and from 0 to 1. After integrating, what value you got? You got 1. So means okay, it's normalized. Now next thing is how you will check like compute the region. So integrate it from that region to its one value. Now you will again get of some values. Now how we will prove its independence or not? So just check the individual functions output. Like for marginal with respect to x will be 2x and marginal with respect to y will be function with respect to y will be 3y square. Now their product is 6xy square which is equal to our function only. So it is independent. Now where we can make mistakes in this concept are like marginals don't determine the joint. Okay. So given the value of x and y, they are infinite. Many valid joint distribution consistent with those marginals. Like this is said by Scalar's theorem. And you cannot assume independence just because you know the marginals, okay? Second thing is like f of xy can be greater than 1. It is valid. Same as the 1D case which we discussed in the last video. Joint PDF is a density, not a probability. It can exceed 1 over small region as long as the double integral equals to 1. Next thing is like order of integration matters for improper integrals. Like for absolutely integrable joint PDF, there is a theorem which is like Fubini's theorem, which guarantees you can switch integration order. But for improper or unusual cases, like you can't do it. Always check absolute integrability first, okay? Then comes next point where you can make mistakes is like joint PDF recovery of PDF requires mixed partial derivative. Okay, so it's just not the partial derivative in one variable. We just make sometimes differentiate it only once and get a marginal PDF derivative. So it's not the joint PDF. Okay. Next thing is like independence check requires equality everywhere. So f of xy is equal to f of x into f of y must hold for all values of xy, not just a few points. Find one point where it fails, and it is enough to conclude the dependence. So finding it holds at several points. It's not enough to conclude independence. Okay. Now, another mistake like will be discrete joint PMF support can be very much sparse. Many values of x and y combination may have probability 0. The table representation um, hides this if you don't list all combination. Okay, so always like always represent your answer in table format. Next is like okay, this I told you. Now, why we are studying this? What is the machine learning connection? So every data set is a sample from an unknown joint distribution. The joint over all features and the label. Machine learning is essentially estimating or exploiting the joint distribution. Okay. Second thing in generative models like GANs diffusion explicitly like model a joint distribution and over a data of like x and latent z, then marginalize out z to get the probability of x. Then third where we use it is like in financial machine learning and risk modeling to separate marginal distribution from dependent structure. It is called as popular. Okay, it lets your model complex joint behavior without fully specifying the joint PDF analytically. Okay, I hope I'm making it easy for you to understand. Okay. Next thing is like multivariate Gaussian. It's like uh, joint PDF factorizes cleanly and characterized entirely by mean vector mu and covariance matrix E. Okay, this will come in our topic number 26, I guess. So there we will discuss this in depth more. So that was all about this video, and in next video we will be studying marginal and conditional distribution. So I hope I explained well from my side, and I hope you like the video. And if you find any kind of mistake, you can just comment me down. Thank you.